Welcome to the Evolution 2.0 podcast, where we explore the intersection of art, technology, business, biology, and spirituality. Here you'll discover new trends in evolution that are changing the way we think about everything. This is your host, Perry Marshall, author of Evolution 2.0, 80/20 Sales and Marketing, and Guides to Ethernet, Google, and Facebook. I'm founder of the Evolution 2.0 Prize, a quest for the missing link between earth science, the information age, and life itself. Let's join the conversation now. So this is Perry Marshall, and I am here with a rather famous and infamous person, Michael Behe. And he's at Lehigh University, and he's one of the pillar guys of the intelligent design movement. And he wrote a very famous book called Darwin's Black Box, probably, what is that, maybe 20 years ago, Michael?
Yeah, it was 96.
Okay, so, and that book has steadily sold, and he is most famous for the phrase irreducible complexity, which furiously angered, I don't know how many old school neo-Darwinists, absolutely made him furious. And the example was the bacterial flagellum, which if you go look it up, is a very complex structure, and it needs just about all of those parts in order to work. And as an engineer, I looked at that and I go, well, of course things are irreducibly complex. Like, what could be more blindingly obvious? Nevertheless, many people seem to convince a lot of people that there's no such thing, and Darwinian evolution can solve all that. They never convinced me successfully that gradual stepwise Darwinian evolution could solve that. And I didn't really think their examples were particularly good. And so that might sound like I would just totally be in Michael's camp. Well, Michael also, by the way, has another book called Darwin Devolves. And I had a podcast interview, maybe earlier this year with Bill Cole, and we talked about this book. And But the reason that I wanted to talk to Michael today is because, well, I agree that a lot of things are irreducibly complex, but I also observe that organisms evolve in irreducibly complex ways very often, and you can actually watch what they do, and that the organisms are actually very smart. And so I found myself being probably, 85 to 95% in agreement with the basic facts that you presented in this book. But I didn't agree with the strategy or the exact conclusions. And I thought this would be a very, very interesting conversation that we could have. And so, Michael, welcome. I'm very glad to have you here.
Thanks. I'm looking forward to find out what that 10 to 15% is.
Yeah, well, and so the a huge moment in my investigation, and this probably goes back about 12 or 13 years, was when I discovered Barbara McClintock and Jim Shapiro. And when it might not seem like a big deal to a lot of people, but when I learned that McClintock damaged a plant's DNA, and the plant went and took bits and pieces of transposable elements in various sections of coding sequences and moved them around, repaired itself in a novel fashion. Like it apparently was constructing a pattern that may have never existed in history before, and went on to repair the problem and reproduce. I thought, oh my word, this changes my entire perspective on evolution. This might seem like a minor fact. This is like a huge world tilting thing. And so this got me down Shapiro's natural genetic engineering, and well, now, as of lately, I've been having conversations with people in cancer research where cancer does things like that. And so, so intelligent design says there's design, and I agree, but I also think the organism does the designing. And so Michael, let me just serve that back to you. I'm sure you have a lot to say about this.
Well,
I probably don't even have
yeah.
to add more. So,
Well, it's interesting. I think a lot depends on what you mean by the organism does the designing. It's one thing to say that an organism can repair damage that's done to its DNA, even that it can move around pieces of DNA that were there. It's another thing to say that that organism can make something new, like say, a bacterial flagellum, which was not there before. And if it can make it from something that was there before, then that material, in my view, was programmed into it or guided or somehow directed intelligently. It's clear that there are really sophisticated systems in the cell and they do sophisticated things, but once they go beyond what they're set up to do, I don't see any evidence that they can invent through a novelty. I pointed out a couple examples of that in Darwin Devolves, the latest book. And one is that, if you look at evolution in nature, say development of the polar bear from the brown bear, you don't see any fancy mechanisms that are obviously involved. If you look at the development of resistance to the drug chloroquine by the malaria parasite, again, there's a couple of tiny point mutations that seem to be involved, pretty much regular Darwinian type natural selection, but nothing fancy like Jim Shapiro talks about. So, I certainly admit that the genome has lots of tricks up its sleeve that perhaps we don't know about, but to deploy those outside of their kind of well-defined duties is, I think, still beyond unintelligent processes.
well, so somewhere implicit in your view is there's a dotted line where whatever we're seeing either was a separate act of creation, I presume, like from one species to another, where there's other things that are more attributable to what is already programmed in. Is that a fair distinction?
Well, it depends on what you mean by that. I don't say that any particular new thing had to be created in a puff of smoke. Mm-hmm. I think the origin, exactly how it was designed, is that we don't have enough evidence right now to decide. I've written in a couple books that, for all I know, all of this might have been programmed into the universe from the beginning. There might be kind of nudges along the way. There might be puff of smoke creation, for all I know. But the one thing that we can tell just by looking at a structure is that it was purposely designed. And that's the minimalist conclusion that I argue for. Just like, if you look at Mount Rushmore, if you hadn't heard of it before, you look at it for the first time. For all you know, it might have been made a zillion years ago. It might have been carved by space aliens, whatever. You don't know how it was made, who did it, why, and so on. But just by looking at it, you can tell it was designed.
So I agree. I agree there's design in biology, and I'd agree there's purpose in biology. In fact, I would go so far as to say that the attempt to eliminate purpose from biology is the biggest mistake in the history of science. I would go so
Yeah.
far as to say that I think it's, in fact, it's plain ridiculous. But now this comes to these fine shades that you just outlined here. You said, well, it could be programmed in like a pool shot at the very beginning of the universe that was just so perfectly positioned right. There could be nudges along the way. Maybe there are puff of smoke, like zebra just appeared munching grass on the savannah one day. I don't know, right? And of course, there's people that would embrace that. But in any case, it's purposefully designed. Well, again, I agree with the conclusion, but in the actual practice of science, where you draw how you address those other possibilities becomes a real experimental question and problem. Because if they're puffs of smoke, well, how are you supposed to study a puffs of smoke, right?
Smoke detectors.
Well, you can't study, like, well, and so this gets to the creationists saying, well, God made certain kinds. And then my question to them is, well, okay, so is the statement that creatures are going to reproduce after their kind is an absolute iron law, or is it only a general principle that can sometimes be violated? And so, like, as best I can judge from the fossil record and genetics and everything, the big leaps are from mergers and hybridizations, which force genome restructuring, which is, go ahead, Michael.
I was just going to say, that may be the case. I don't mind that a bit. Just to take a basic level, if you have a eukaryotic cell without a nucleus and a little bacterial cell joins forces, and you have a nucleus, that's okay with me. But I point out that, in fact, it doesn't explain where the eukaryotic cell came from. It doesn't explain where the prokaryotic cell came from. It doesn't explain how they adjusted to each other. It doesn't say anything in particular. And so I wouldn't really, and that might be proto-science, but I certainly wouldn't consider it to be a scientific explanation. And when you go to look at things in the laboratory, they don't seem to behave like the prototypical evolutionary biologist would expect. That's the thrust of my newer book, that in fact, leaving aside all this other stuff of irreducible complexity and all this fantastic machinery, Darwinian processes actually degrade things much more frequently than they build them. And that's a big problem for unguided evolution.
Well, so, and again, I agree with that too. I'm an electrical engineer. I understand information theory very well. And if all you've got is point mutations and copying errors and natural selection, well, that is not going to get you very far at all. Well, so so I have a friend, Quan Zhang, who is used to teach at University of Tennessee, and he did this experiment where he put bacteria and amoeba, X bacteria and amoeba proteus in a petri dish, and they fought with each other like cats and dogs for 18 months. And at the end of the 18 months, they had merged together, and they had consolidated. So each of those organisms had given up parts of its DNA. They had consolidated functions. They were now operating as one organism, and if you separated them, they both died, which is a common definition of a true symbiotic relationship. Now, that's not exactly the same as proving that a chloroplast and a blue-green algae came together with a a plant cell and formed the first chloroplast. But it's not that different. And you can, you know, being that he did that, you could probably rewind the tape or rerun the experiment and get finer and finer and finer details on how these two organisms choreographed.
Well, that's fine. You know, that sounds perfectly okay with me. But I would say that you have to look at the genetic level. You have to look at the molecular details of what's going on and ask yourself, is anything constructive at the molecular level being produced? That is,
Okay.
are there any new genes, any new molecular machines, any new proteins? And as you might expect from my new book, I would expect that in the course of these two organisms adjusting to each other, that the most significant mutations would be ones that lost function, that gave up capabilities that either one already had. And, you know, let me give an analogy for viewers. The way I think of this, that, you know, if you had a car and you were driving along and out of a window from an apartment building, an air conditioner fell down and somehow plugged itself into your car, now you have a car with air conditioning. That's great. But it doesn't explain, you know, where the machinery came from in the first place so as to be able to merge together.
Well, if that happened to your car, well, I think you also have an obvious problem that dropping an air conditioner into your car window does not give you a car with air conditioning until hoses are hooked up and electricity is hooked up and the right entrances and exits, right? And but then this is exactly what we see cells doing. So amoeba, proteus, and X bacteria literally coordinating their functions to eliminate duplicate roles. That's extremely impressive. And so like when I look at that, I go, that is a rabbit trail that is well worth pursuing. And furthermore, it's a rabbit trail that's mostly been ignored by the majority of the profession because they've been programmed, everybody's been programmed to be a neo-Darwinist from the word go.
That's true, but you know, I would be more impressed if the two organisms got together and not only didn't just eliminate overlapping functions, but developed new ones. You know, it's okay when two businesses merge. You know, you can throw out one of the offices, advertising of this, sales of that, but you know, if you want to explain where life came from, you've got to explain how new stuff comes about. So, and again, I'd emphasize, even with those, the amoeba and the bug that your friend studied, you have to look at the genes, have to look at the genetic level, the molecular level, to tell exactly what's going on, because evolution, the mutations upon which evolution feeds are changes in molecules. And so if you want to understand how it proceeds, you got to look at the molecular changes associated with any new strain that you're studying.
So I've been having some very interesting conversations with a guy named Henry Heng, who is at Wayne State University in Detroit, and he's a cancer researcher. And he came to very similar conclusions as I have, not by reading the same authors that I read, but by doing karyotype studies of cancer and tumors. So karyotyping is when you look at the entire gene and the entire chromosome and how the whole entire thing is structured. And he he says there's a stage in the development of cancer where, especially if the cancer is being attacked by chemo or by the body's immune system, there's a stage that will come where it does massive genetic reorganization, and not just granular changes, but massive reshufflings. He said most of the time, DNA sequencing does not reveal the extent of the changes, because at the level of individual genes, things don't change very much, but the relationships between all the genes do change. And so the expression of genes changes, and the epigenome changes. And then all of a sudden you have a new cancer cell that the old drugs can't fight anymore. And this is one of the reasons people die of cancer is, well, it looked like the chemo was working, and then all of a sudden, the thing went out of control. And so, and so he was doing this for about 5 years, and he realized that the entire genomic model on which most cancer research is based couldn't possibly be right. And so as far as I can tell, we see cancer cells creating new forms and new structures. They eventually kill themselves in the host, but they make an awful lot of progress in the process.
Mm-hmm.
Well, so I guess this almost brings me to a political question. So if I'm Michael Behe, or if I'm, any of the intelligent design guys, and you hear all of the objections and criticisms, it seems like your job would be easier if you incorporated as little supernatural intervention as humanly possible, and hypothesized as much internal reorganization and restructuring as you could possibly grant it. And then now you have a testable hypothesis, because the common criticism is, well, if this is designed from the outside, if there's any kind of a puff of smoke, if there's any kind of a miracle, then you don't have a testable hypothesis. Yes, you may have an inference. So I don't know, Michael, how do you personally approach that question?
Well, there's a couple related questions, and I would say, first of all, that if you say that this, say, bacterial flagellum, or even this disulfide bond, or something simpler, this is beyond what we would expect from Darwinian processes, or even any other cellular rearrangements or something. I think it required purposeful, intelligent planning, or some such thing.
Mm-hmm.
That there's a necessary implication, is that you won't be able to get something like that by undirected changes. So if, for example, Richard Lenski, the biologist from Michigan State, goes in his laboratory and grows E. coli for 60,000 generations or so, and he comes up with some new, molecular machine, new, something fancy new, I would have a lot of explaining to do. So I would say that, in fact, intelligent design is easily falsifiable, at least, simply by showing that things that I claim can't evolve by undirected processes do, in fact, do so. How I see it is that folks like Darwinists, or even folks like Jim Shapiro and non-Darwinian, unintelligent evolutionary biologists, they say is that somehow undirected processes or fancy processes in the cell could produce something new. And I say, okay, great, show me. And they say, well, this experiment failed probably because we didn't start with the right bacteria, or we didn't have the right conditions, or we didn't feed it the right food, or some such thing. And they could always wiggle out of negative results and claim that, they just didn't get right conditions or they had to wait longer. So it seems to me that actually the unintelligent evolutionary folks are the ones that don't really have a critical test for their hypothesis. As far as huff of smoke stuff, I of course am always careful to say that I don't know how these things were designed, and that for all I know, all the information for this could have been included at the beginning of the universe and unfolded over time, but that it had to be purposely planned in there. So I minimize the number of what you might think of as supernatural acts that are required to one. Additionally, just one more point is that if you say that the cell can rearrange itself, or that if you say that Darwinian processes are necessary or sufficient to account for life, then of course intelligent design is not necessary. If you say that the cell itself can do fancy stuff, I would say, number one, show me, and number two, are you attributing intelligence to the proteins and systems themselves, so that, say, like a computer program that's built to do your finances actually learns how to draw pictures also? Are you attributing actual intelligence not to some outside entity, but to the pieces of the cell itself?
So I think we're at the heart of the issue now. So yeah, so I'm glad we got here. So let me recap what you said and just make sure we're in alignment here.
Okay.
So you have puff of smoke scenarios, which have their obvious problems. Okay. Then you've got two other possibilities. Either the information is somehow programmed at the very beginning of the universe in the pool shot sort of way, right? So that's an option. Or an option is the intelligence is embedded so that the computer program literally does learn to do new things. So those are kind of three scenarios that you laid out there. Is that?
No, I actually said that I didn't talk about a computer learning to do new things. I think that's very restricted, and I'm kind of skeptical of that. I'm saying that there might be guidance along the way. Maybe mutations are put up for selection at the proper times, or the environment is so constructed that it favors something or other. I'm not saying I believe any of the particulars. I'm not saying I believe there was a puff of smoke or anything. I'm just saying that as far as we know, and with the evidence we have, we can't rule out any of those things.
Okay. Well, so I think the position you've taken of, any one of these three or four interpretations could be correct, and I'm not picking one. They're all on the table. I think in one sense that gives you an openness to see what develops as science goes forward. It also makes you very simpatico with religious people of various stripes who almost inherently see purpose and design in the universe, because religious people almost always see the world that way. It puts you in a real war with many people in your profession, because they don't like the fact that you've pointed out that the emperor has no clothes. They certainly don't like that, right? But then it's almost like they can argue that you're not, well, we don't really know what you believe, Michael. You're not really committing to any particular scenario. So you're criticizing all of us, but you're not solving anything. So am I anywhere close to accurate with that?
Yeah, sure. I certainly do get that criticism a lot. But what's the alternative? The alternative is to suggest something for which we don't have any evidence. And we're going, however you look at it, whatever made life develop and unfold and so on is really different from what we see going on these days, something very unusual. And so why eliminate this possibility because it strikes some group as far-fetched, or that one because it strikes another group as far-fetched? They're all far-fetched. A good example to keep in mind is the Big Bang theory. And you remember that before the 1930s, most physicists thought that the universe was eternal and unchanging. And then the motions of galaxies were noticed. The Big Bang theory was proposed, that the universe had a beginning. And that struck many physicists as a puff of smoke, as a creation. Maybe, God started this universe in motion. But and some explicitly said that's not a scientific idea, that science itself requires an eternal universe. And so any suggestion of a Big Bang was ipso facto unscientific. I kind of regard intelligent design the same way, that we've got this evidence for design, just like folks had evidence that the universe was expanding, and the natural conclusion is, in one case, it came from an explosion, the other that it really was designed. And it might have theological implications, but that's not my job.
Right.
Let other people worry about it. I'm just pointing out how the evidence strikes me and what I see as some possibilities from that.
Well, you do make a great point in the book that your hands are quite full just dealing with the mystery itself, physically speaking, without trying to get into a theological conversation, which is like a whole nother realm, which I appreciated. I thought that was a great point.
Yeah.
It's like, hey, there's no rule that says I have to debate this God thing. I can leave that for the philosophers and theologians.
Yeah, my graduate work was in biochemistry, not theology or philosophy. So I defer to these other guys, but I will in my own area expertise, I will say what I think is warranted.
Well, so you raised a question a few minutes ago. You said, are you attributing intelligence to the proteins and the systems? So yes. I'd love to talk to you about that. So why don't you elaborate more, just so make sure everybody knows what you mean?
Well, when you say that a system rearranges itself in order to do something, or if you're trying to explain how a piece of molecular machinery, like say the flagellum, came about, do you think that those proteins have the capacity to plan in advance, to conceptualize these things, or is it just because of their current abilities that it makes it more probable that they will stumble upon some of these new complex systems?
Well, I can tell you how I answer the question. Fair? So I have a great book here by Howard Patee. It's called Laws, Language, and Life. Howard is, I think, 93. And for 60 years, he has been saying that the mind-body problem that philosophers have famously argued about for 2,500 years goes all the way down to the cellular level. He says the same question that you can ask about So I say, Michael, raise your left arm, and you go, no. Or you go, or you go, okay, you made a choice. Well, the philosophers have an argument. Some people go, well, Michael didn't really have a choice. Everything is just predetermined by programs, and it's just a very, 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 very complicated chain of cause and effect of weather that determined what Michael did with his arm. And there's other people that go, no, Michael is a being who has agency, and Michael decided to raise his left arm because he wanted to, and it's a choice, okay? And so this argument has been going on for thousands of years. Well, first, I think you do have a choice, okay? That's what I believe. In fact, I think all civilization is predicated on the assumption that people actually have choices. And I think that animals have choices, at least in some degree, maybe not as much as we do, but in some degree. And I think even cells, and I think Barbara McClintock's plant decided how it was going to move all those transposons around, and that really, whether we're talking about the immune system or any of this kind of stuff at the cellular level of how, the most recent Nobel Prize just a few weeks ago was shown for guys who showed that changing oxygen levels would trigger changes, rearrangements in the genome and gene expression, and literally change the DNA. And I believe that these are choices, information theory, ones and zero. How many bits, how many bytes? You go buy a 1 gigabyte USB stick. 1 gigabyte is how many choices the USB stick is capable of storing. And so you have to have choices. So I believe that cells are making decisions and making choices a little bit more like how humans do than anything else. Now, what we don't know is what is the locus of control, or where is that, like, at what point is that choice being made? And I don't know. So I hope that sounds like an answer.
That's interesting, but I would say, where did those ones and zeros come from in the first place? Did they build themselves up, or were they added to the machinery? I certainly believe that a USB stick can store a certain amount of information, and that's great, but the USB stick doesn't explain where the information came from. Perhaps a cell can store large amounts of information, but it by itself doesn't explain where it came from. If it was added to the cell, then that's just the pre-programming that is one option of intelligent design. If the cell is actually deciding itself, then that strikes me as a little exotic and outside of our experience. And another reason that I don't really subscribe to that much inventiveness in the cell is the examples I talked to you about before with malaria. Has a huge number of chances. It never really developed anything new in response to this deadly drug chloroquine that was killing it in droves. The human genome, in its fight with malaria, there's only been a handful of mutations that have helped, none of them in the immune system, and all but the sickle mutation are breaking or degrading pre-existing genes. So I haven't seen any experimental support or really definitive support for the idea that these processes can really come up with novel features.
Well, so I'm not sure I can give you an adequate response to malaria because I have not studied that very much. Now, You were something you said triggered a thought, and then I lost it, and I apologize. Yeah, I'm gonna, and we'll edit the recording here.
Okay, so is it
I had a
grading?
I thought I had let me see if I've got a note here.
Can bring it up if it comes back.
Yeah. So, no, it was really good too. Well, just give me a quick second. I think I've got a.
Okay.
Oh, okay. So David Prescott discovered that ciliated protozoa could cut their DNA into 100,000 pieces and rearrange it and do this in real time. And I would have to go look up the paper to find out in response to exactly what. We know that when you hybridize plants and animals together, there is a process called hybrid dysgenesis, where they will do a whole bunch of culling and deleting of genes, and there will be a period of instability where the genome is being rearranged. Now, genetic evidence suggests that where vertebrates came from was a tunicate, which is kind of like a sea squirt, mated with a hagfish, which is an invertebrate, and the result was a vertebrate. Now, nobody's done this in real time, so they have not probably adequately answered the question that you're asking. But when you look at vertebrates and then you look at those two invertebrates, it looks like vertebrates are a result of that genome merger. Mm-hmm. And it looks like jawed vertebrates were the result of another hybridization merger. So each one of those doubles the number of chromosomes. And then we know that you can get corn by mixing emmer wheats with goat grass, and that people hybridize plants all the time. So when I look at these kind of changes, I don't, as a person with a software engineering and computer programming background, I've never seen programs that could do something like that just from whatever was previously programmed. It strikes me that there are actual choices being made based on the situations. And I've certainly read a lot of papers about extremely sophisticated cellular signaling systems that exist. So the balance of evidence seems to suggest that organisms have agency over their own DNA, and that saying that we don't really have evidence for that isn't any really different than saying, well, we don't have evidence for what makes humans intelligent. Like it's really all the same question. So sorry for the somewhat cumbersome answer.
No, yeah, that's really interesting. But even if you have two different types of organisms and they merge and a different kind of organism is produced, as in these examples, it still doesn't say what is driving that process. You're assuming that once they do this, then it follows straightforwardly from the laws of genetics or something, that they will produce some new kind of organism. And I think that's a claim that has to be backed up. And I don't see, I don't think it's obvious. The second thing is one other thing is that you talk about the hybridization of corn and other such things, and that's very interesting. But one thing you have to keep in mind, that a point that I made in my new book, Darwin Devolves, is that the time scale for these changes, say hybridization or gene duplication or lots of other things, is many orders of magnitude greater than the degradatory mutations that are routinely seen in organisms in experimental evolution protocols. So, for example, I talked about Richard Lenski, and he is letting E. coli grow in his lab in Michigan State. And after a long time, he looked at the 30 highest, most highly selected mutations, and they turned out that they were all degradations in pre-existing genes. And that's only been, 30 years or so. And most of them have appeared after a couple years. Whereas these other processes of speciation and stuff, they're projected to take millions of years. And the organisms aren't going to be twiddling their thumbs waiting for these bigger, more constructive things to come along. Evolutionary theory predicts that the first thing that comes along has the best chance of being incorporated into the species. And so I'm hesitate about word pictures of complex systems and so on. Oh, and one other thing I just remembered. It's interesting. You're talking about computer programs about merging and getting along. I am no computer programmer or anything like that, but I've done little things, and you can include libraries in programs. There are libraries that are built like math libraries, and you can say include math library. And from what I understand, the program and the compiler and whatever merges a pre-existing program with what you just wrote, takes what it needs, tosses out the rest. So that might be, but all of it, of course, was intelligently designed. So that might be an example of that in computer programming.
So on Lenski's experiments, so let me just explain Lenski for those who don't know. So Richard Lenski is a guy in Lansing, Michigan. He's got this thing called the Evolving Bacteria Lab or something.
Yeah.
And he's, for, I don't know, 20 or 30 years, he's had these bacteria, and, you know, they feed them sugar and they just keep reproducing. And I think they're up to 60,000 generations. And they've been studying, well, how are these bacteria evolving? And the answer is, for the most part, they're not really evolving at all. Now, my contention is, well, they're never going to evolve because he's not putting them in a hostile environment. and they're never going to do anything interesting because there's nothing to have a symbiotic merger with. Like my understanding of evolution is not much happens unless you put systems under extreme stress, and you're never going to get large changes unless you have mergers or genome reorganizations. And so I don't think his Evolving Bacteria Lab is going to accomplish much of anything, because it's an artificially safe ecosystem to begin with.
Yeah. Well,
I don't think it teaches you that much.
Well, I could, or playing devil's advocate, I could say, well, why don't one of those E. coli's duplicate its genome? Now you've got a bacteria that has twice as much DNA as its colleagues. And then it could get rid of some and not the other. It could rearrange it. Why isn't it rearranging its own DNA to do something?
Well, you have to have sexual reproduction to have genome duplication, and the bacteria aren't sexual. So that would be
one
as far
problem. Oh, I bet you could figure out something though.
Well, yeah,
and,
I'm not sure.
And one other thing is, let's see. Now I'm having my own senior moment here. One other thing.
We'll edit it out. Don't worry about it, Michael. It's fine.
Is that, oh yes, the most important feature, I think, of an environment is not necessarily its temperature or whatever, it's the presence of other organisms. And whatever E. coli cell changes in such a way that it's got an edge over anything else will rapidly take over the population and eliminate the progeny of any of the other ones. So even though it's a uniform environment and it's kept nice and steady with minimal supply of nutrients and so on, they are competing with each other. And so that makes it more complex than you might think.
Okay. Well, let's just kind of close up with, I think you asked a really great question. What is driving the process, right? If Barbara's corn plants or these mergers or whatever are, if the cell is actually doing this as some kind of a proactive thing of its own resourcefulness, what is driving the process? And you know what? I think that's the question. Like, well, what gives life its spark, and what gives biology its impetus to do what it does, right? Like, you know, I got a rock over in my shelf and that rock's just gonna sit there, right? But I got a cat, right? And the cat acts in its own best interest. And like, really, Michael, I think this is the crowning unanswered question. And the reason that eliminating teleology from biology is the biggest mistake is they're like, well, we just don't feel like answering that question, so we're just going to pretend it doesn't exist.
Right. Yeah. That's right. By fiat, you rid yourself of what you don't like. Well, we'll just say that really isn't true. It's really just some sort of outplaying of the laws of physics somehow. Although we can't describe how it works, and that's a terrible way to do science. To overlook something because you don't like the implications of it.
Yeah, and so personally, I suspect if somebody wins my $10 million prize, they will win it by figuring out the answer to this question. Like, well, what is the thing? Paul Davies has a great book called Demon in the Machine, where he explores this question from a whole bunch of angles. He's saying, well, cells reverse entropy. So not thermodynamic entropy, but information entropy. You have ion channels, and, a cell keeps some things out and lets other things in. Mm-hmm. Well, whatever that is, right? I mean, that's, it's like we're grasping at the problem.
Yeah. Right? Yeah, sure. The basic question of intelligence and consciousness, which seems to be behind life one way or another, either explicitly by somebody actually building these things, or by attributing it to cells that somehow became this. That's the problem that dare not speak its name in biology.
Yes. Well, we need to wrap, but this book, Darwin Devolves, Michael Behe, very interesting. I've got all kinds of underlines and different things. And, as you can tell from my interview, we approached the answers from somewhat different directions, but I think probably our facts are largely in agreement. And, and Michael, I have to commend you. You have endured much scorn and much criticism, and you're still paddling and you're still trekking along, and I admire that. And so I want to congratulate you for provoking a whole industry.
And I say thanks for tenure. Thank you for the institution of tenure.
Yes.
So
well, that's
wonderful thing.
Well, Michael, this has been great. Thank you for taking this time with me today, and I hope readers will use your ideas to challenge their own, and we'll catch you next time, Michael.
Great.
Thank you very much.
It was great to be on with you, Perry. Good luck.
All right. Take care. Until next time, this is the Evolution 2.0 podcast, bridging science, technology, business, and the big questions. To ensure you never miss an episode, subscribe on iTunes or on your preferred player. If you like the show, rate us on iTunes. Join our email list and social media at cosmicfingerprints.com.